Now, this is one of the most expected topic for any of your exams. Okay, this topic can be broadly categorized into two parts, which is either rarer to denser or denser to rarer medium. What is this? This is refraction from curved surfaces. So curved surfaces where object is placed depends on position of object, whether it is the refraction is going to be rarer to denser or the refraction is going from denser to rarer. Even in this case, it is further classified into convex and concave surface, both ways. This is convex and concave surface, and here convex further gives you either real image or virtual image, but here this is virtual image. Basically this part, this convex, can also give you real image depending on the position of object, but in your syllabus books you have, it is only virtual image is only mentioned. Alright, the easy part is all of these topics will have just one answer, which is for rarer to denser medium, and similarly these two topics will have another answer for denser to rarer medium. So basically we have got two broad categorization and two answers, irrespective of the fact that there are further 5 different types of derivations. Now the theme, the idea, the way, the method and everything remains same. All you have to focus is about how to make the ray diagram. Once your ray diagram is clear, you can always get through the answer very easily. I'll show you the technique. You just remember techniques, just 2 steps and you'll get the answer. We'll do for rarer to denser, the convex and the real image. Okay, this is what we are doing, the convex and the real image. For this, how are you going to expect questions from this topic? The questions would be: find a relation between object distance, image distance, radius of curvature and refractive indices of two mediums when refraction is taking place from rarer to denser or denser to rarer will be elaborated, and either it will say when rarer to denser, denser to rarer, or they can also specify the position of object, that when object is placed in this medium or that medium. That will automatically tell you whether the refraction is from denser to rarer or rarer to denser. My principal axis, this is my convex surface. Okay, this is my convex medium. Basically this surface is convex and this is whole convex medium. First of all, the first thing you have to draw before starting the ray diagram is the normal. Normal is the what? Is the perpendicular on the surface. Imagine that object is placed here. If you guys want me to use different colors, I can use that. Object is placed here, a ray which is incident on this convex surface or this whole convex medium. This convex medium is what? It is differentiating two different refractive indices of 1 and 2. Okay, in many books you guys also use the this thing mu as n, right? N1 and N2, right? Whatever. Now this ray is supposed to bend from, it is going from where? Ray mu1 to mu2. Right now mu2 is greater than mu1, that means the ray is traveling from rarer to denser medium. Okay, so it is supposed to bend from what? Towards the normal when it is going from rarer to denser, and then the word normal comes into play. The normal would be what? The perpendicular on perpendicular. How would you draw perpendicular on a curved surface? You will just extend the radius. These are the basic things which we have already discussed, right? So now we can know that if it is bending towards the normal or away from the normal by making few dots, and you will see. Now this is how ray should have gone in the absence of the medium, like this, but due to this medium it will bend towards the normal, so the ray will go like this towards the medium bend. Okay, this is the formation of image. This is actually a image diagram with a bit of what? Error. Why? This much bending never happens. Okay, even in your books they have shown diagrams like this, but I'll tell you, this much bending never happens. The ray is supposed to go like this and it has bent this much angle. No, it doesn't. Usually what happens, when this object is placed at larger distance, then this ray which is coming from object to the normal or at the point of incidence, this ray is almost like this, almost parallel to the principal axis, and this ray, when it bends at this angle, this is still possible. But to show what is overall happening, we have to make such diagrams. So yes, keep this thing in mind that these kind of ray diagrams, and practically they are not existing, but yes, virtually we are showing it to represent the formation of image and to derive the expression. Now, which is angle I and which is angle R? I'll keep on removing the not required things to save my space here, because I have this less space. Which is angle I and R? The angle between incident ray and the normal is I, and refracted ray and the normal is R. Alright? See, just remember two steps in this whole derivation. First is, I'm not writing that this is step number 1, but you have to. According to Snell's law. This topic we have done in really good detail, right? The Snell's law. So according to Snell's law, sin I over sin R is equal to what? 1 mu 2 or 2 mu 1? The ray is going from medium 1 to medium 2, that means this is 1 mu 2. Alright? This 1 mu 2 becomes what? Mu 2 upon mu 1. Sin I upon sin R. We have already discussed about this thing being getting converted into this formation, right? That this is actually the reverse of this. Then if you can write a statement, if theta is small, then sin theta tends to theta and tan theta also tends to theta. This line is very much required. Why? Guys, I am going to rub that part of the diagram, so please keep writing with me, or you can obviously pause the video. This is the beauty of this program part, what we are doing. You can always pause us and write whatever you want to. In our days, we never had this facility, so you guys are lucky. From this point, what will I get? If sin theta is tending towards theta, I will get, or I should not do this, or not do this dirty part. I'll write here, this is what? I upon R is equal to mu 2 over mu 1, cross multiply, I'll get mu 1 into I is equal to mu 2 into R, right? This is done. This is the end of step 1, which I started from here. Now for step 2, remember, for object, let me make few notations here. This was image, this is normal, so this distance is radius of curvature, right? So write the notations for 3 angles, alpha, beta and gamma. For object, this is always alpha, for image this is always beta, and for this normal this is always gamma. So alpha, beta, gamma, and all these angles are facing towards the curvature. Let it be any case, any diagram, any situation, alpha, beta and gamma have to be facing towards the curvature, okay, towards the face where refraction is taking place. And I and R are obvious. I and R don't need to be depending on the curvature. It has to be on what? Incident ray and normal. That's it. So using the triangle property that external angle of a triangle is equal to sum of two interior opposite angles. This is external angle property, I guess. You guys did it in class 10th. From this triangle, this line, this part is extended. That means this angle would be equal to this plus this. So angle I is equal to alpha plus gamma. Alpha plus gamma. And this angle gamma is equal to R plus beta, right? Gamma is equal to R plus beta. That means R is equal to gamma minus beta, right? So these two things, if any one of you or if anyone just write these two equations correctly, the whole derivation is going to fall in the place automatically. You just have to write these two equations correctly. This is the point where whole derivation is actually depending on. See how? Instead of I am writing instead of I, this is alpha plus gamma, and instead of R, I have gamma minus beta. Right? I've used this point and this point. Now I'll be using this property. When theta is small, tan theta also tends to theta. So instead of alpha, gamma, gamma and beta, I'll be using tan. I'll be using tan alpha plus tan gamma mu 2 tan gamma minus tan beta. Okay? Yes. Instead of tan, what is tan? Height upon base. If I have to take tan alpha, I have to do some height upon base, but I don't have any height there, so I am going to make a construction. Let it be xy. Okay? Xy. So now I have all the heights and bases. This is for tan alpha. Mu 1, tan alpha is perpendicular upon base, height xy upon ox. Guys, what is this point called? This particular point, this is called what? Pole. So I'll represent it with P. This point will be coming now, so I thought mention it before. Then tan gamma. Tan gamma is xy upon xr. What is this xp? This was tan alpha. Tan alpha is xy upon ox. Oh, now I get it. This is my very good handwriting. This was xy upon ox. Then tan gamma. Tan gamma is xy upon xr. Xy upon xr is equal to mu 2 tan gamma, again xy upon xr, minus tan beta. Tan beta is this, that is xy upon xi upon xi. Okay, I'll go out of the frame many times. I have less space because I write big. Now after this, what is next step? You can take the xy common and cancel out from each side, right? So I'm doing it right here, so that you guys write it in next step, take out xy common and cancel out. I'm doing it right here. I'll save one step. Now what are we left with? We are left with this mu 1. Okay, I'll not write this equation right now. What I'll do this. There is a statement that since aperture, what is aperture? We have discussed about this thing. Aperture is the bulge, how much part the bulged surface is outside or inside. Suppose this is the flat surface right now, but it is going to be curved. So this is less curvature, this is more curvature, this is very more curvature. This much. Basically, you take a football, slide it from the side. The depth of the surface from the straight sliced part is called aperture. Okay. So since aperture is small, what? Ox is very much equal to OP. Ox can be taken as equal to OP. So Ox is almost equal to OP. That's first. Then XR is PR. XR is almost equal to PR. And then XI is almost equal to PI. Done? So I'll use this part. Hope you guys have already noted it down. If not, pause the video right now. Then, putting these three values in this equation, guys, remember this fact. We never tend to learn the whole derivation. If you mug it up, you're definitely going to make some mistake and you're going to forget it. Just remember the basic 2 points or 2 things from where the equation started, and now you will automatically go through the whole derivation. Okay. In this case, there was 2 points. Number 1, Snell's law, and number 2, the application of or the conversion of I and R in terms of alpha, beta and gamma. Chalo, let's move on to this next step. This is mu 1 over OX, mu 1 upon OX, which I am going to take as OP plus mu1 upon XR, which is PR, is equal to again mu2 upon X. What is this term? Mu2 upon X. This was gamma. Gamma is XR. Okay, this is XR. Mu2 upon XR. And instead of XR, we are having PR minus mu2 upon IXI, which is PI. Now, the smart thing comes into play, which is what? OP is object distance, which is U. PR is radius of curvature, which is R. And with this thing, I would suggest you guys not to use R, which I did. Instead of R, use center of curvature C. That would be more appropriate instead of C. But I am not going to rub it all and start from the beginning to just replace one of my alphabet. You guys do that. So this thing may R, the radius of curvature, and then I have to convert PI. PI is the image distance, which is V. Okay. So this equations become mu1 upon OP. OP is U, right? Have I written this part right? Obviously not, because U is again on the left side, which I will be taking as negative. So I should have written it like this, mu1 upon minus U. But again, I am not going to write like this. I am going to write it what? Minus mu1 upon U. One and the same thing. Plus mu1 upon PR. R, that is mu1 upon R, which is equal to mu2. Mu2 is mu2 upon PR. PR is again R minus mu2 upon PI. What is PI? PI is V. Sorted. So taking this term, this side, I'll be getting mu2 upon V. Time to rub. Pause the video if you haven't noted it down. And I think this much will do. This part, this thing goes there. So I'm having mu2 over V, then this term minus mu1 upon U is equal to mu2 upon R, and I am taking this term here. So it will become minus mu1 upon R, right? So mu2 upon R minus mu1 upon R gives you what? Mu2 minus mu1 over R. This is our final equation. This is the equation for rarer to denser format. Now I give you a trick how to remember this formula, or both of these formula for denser to rarer. Remember any one. If you remember this, then the other formula would be denser to rarer would be mu1 over V minus mu2 over U is equal to minus of mu2 minus mu1 over R. Now how do I remember this? Just replace 1 by 2 and 2 by 1 in this equation. This equation will automatically come out. This is for what? Rarer to denser, and this is for denser to rarer. These two equations will be used again in lens maker's formula. Now we have known the answer, we have known the technique. The same technique is going to be used in every situation and every diagram. I'll make another diagram for the same sort of starting, which is convex surface, rarer to denser, but this time we have to have a virtual image. So see the diagram. We want virtual diagram. For virtual diagram, what can happen? This object is going to be placed a bit near to the surface, due to what? Due to which this ray is going to bend, but is not going to bend so much that it is going to meet the principal, the optical axis, the principal axis, right? It is going to bend and it is going to meet somewhere here, so that the extended portion of it is going to give you the virtual image. See the diagram. It is going to be a rough one, so get used to bad drawings. This is again my rarer to denser format. The object. Object this time I'm taking it a bit close here. So this is my object O. Then the normal part. Normal, first of all, normal. This time you are going to mention it C, not R, remember. And then the ray, which should have gone like this in the absence of any other medium, will bend towards the normal, but it will not going to bend so much normally that it is not going to bend so much that it will meet this principal axis. Instead, it is going to meet the medium somewhere here. So where is the image? Image is extend this line, you will get your image. So this time this is what? This is the virtual image. Now start writing I, R, alpha, beta and gamma and give the relation. If you can do this right now, I'm sure that you are going to do all those relations, but I'll draw it for you. I'll complete the diagram for you. The diagram is actually complete now. I just have to mention the I, R, alpha, beta, gamma and the relation between them. First of all, the angle between incident ray and the normal is angle of incidence. Then angle between normal and the refracted rays are, which is alpha, beta, gamma. For object, it is always alpha. This is alpha. For image, this is always gamma, right? Wrong. It is always beta. And for normal, it is always gamma. Cool? This was, what is this symbol? It is supposed to be I, but I feel it is something like an alien symbol. Alright. So, for alpha, beta, gamma, the relation. What would be the relation? Okay, this is actually easy. It is still easier than this diagram. How? This I is the external angle of this triangle, right? So, the I is equal to alpha plus gamma. That was quite straight. And again, R is the external angle of this triangle, right? So, R is what? Beta plus gamma. Oh, so this was actually pretty easy, beta plus gamma. This was pretty straightforward and very easy. So I'll give you another diagram and then we are going to solve the derivation. We are going to do the denser to rare format and you guys have to figure out if you can give the relation between I, R, alpha, beta and gamma or not, okay?